It's Saturday here. The temperature is trying to get above freezing. All my hoses are froze up going to my water troughs, and so we've been carrying buckets, and this has gone on for a spell. I think we're toward the end of us. Speaking of that, the weather was actually interfering with the time it took us to get through week one. We were basically dealing with that week for a while, and I know it affected me and probably some of you. I think there's a couple of students that forgot that they were enrolled in the school, and you get busy, and that seems like, how could you forget that? Well, I could. You just get busy. Things, when everything freezes up, it's a mess. But that's done or getting done, and we have to, we're there's no we've got some time here. But here's what it is. I remember, if you remember, I sent out an announcement, and then what I was wanting to do is, if you, is not have you in the next or the subsequent week until you finish the current week that you're in. Trust me, this will help us all in the long run. Now, if something comes up and I've overlooked and you see that this is not going to work, even if it's for you for some reason, let me know. But until that time, that's what I'm going to do. I want you to finish the week you're in before you move to the next week. Now, I'm not going to hold. I'm going to go ahead and open up, like, this is week 3, I think. Yeah. Now, when the time comes to open week 4, I'll open it. But if you haven't finished week 4, don't go jumping off in there. Things are not getting easier. They're going to get a little bit, and it's scaffold. The things that we're going through now will help you on the things we'll be going through later on. I will say, though, that week 4 is going to be kind of uh, a rest from all these tedious numbers and things like that. Uh, and we'll be talking about some equipment. I'll leave a lot of the uh, of the learning up to you. Like, read it. It's about asphalt machines, uh, road equipment. Trimmers and things that we just don't talk about that much. And I know we got some folks enrolled here that I know one for sure has a great deal of experience in trimmers and lay down machines. Maybe we come up with a discussion that that he will pitch in and help us all out, explaining some things that maybe the book didn't go into detail or left out. But at any rate, so you're looking at a sketch I just made. Now, you're not going to be seeing this video until Monday morning, but it's Saturday. I just made this sketch, and I turned my video platform on, and the sketch is on it. So this is where I'm going to start with my little sketch. What you're looking at is just a hand-drawn uh, beginning of a trench, a beginning of a trench right here. And these words are like, this is your bedding. We'll be talking about this stuff. And then your pipe goes in there, and then the flow line of the pipe is the uh, the bottom inside diameter. It's called the invert, and you'll have to calculate all that stuff in. But this thing's going to talk about setting up a laser to dig a trench that has either a rise or a fall, depending on which direction you're going. And and to me, it kind of got me a little bit confused, because it first says, set your laser pointing down the trench, and then it says you don't have to. You can set it parallel to the trench. So I've dug many trenches for stormwater and stuff like that, and this was my setup. Now, these stakes out here and hubs will be referred to in the book. Uh, and you can set, this is my laser, you can set it off to the side. Uh, and all these stakes, you can't read it. I didn't intend for you to. But you know, these all, I got a little circle with the 10-foot offset, 10-foot offset, and this is what a survey is. This is what's going to look like, you know, and each stake will have information for that station. See, I put little station numbers up here, and they're 20 feet, as you can calculate, because I got 80 feet drawn up here, and you can tell by the numbering. Now, my last note I just made was like, don't forget that the rise and fall, whichever you desire, is based on calculating the difference in your proposed grade down here at the very, very bottom, your subgrade, and the existing grade. The existing grade will be the top of the hub. And you'll find that we're going to set up and shoot the top of the hub, and we're going to use that reading, and we're going to calculate how to figure in the cut and all this other stuff down here to determine what that reading is. Now, in my road and the building video, we did the same kind of stuff. I just don't feel like I really got through. I don't think I conveyed, you know, what was in my mind, and there was not enough pictures, and it's really kind of hard to describe all this stuff. But anyway, this is what we were doing. We were shooting the top of a hub, right? And then we were adding or subtracting, whether it was a fill or a cut. If it was a cut, we were subtracting the cut plus, and not plus, but and we were subtracting the thickness of the pipe wall. We were subtracting the I can't remember what they called it, but the whole cut down to the subgrade. All of that we added up to do that. And as you recall, you take that reading, and they had some examples in the book. This one does. So let's say we read, and I'll get to these again in a minute. Let's say we read 2.6. Okay, that means you got your rod sitting here. And by the way, the book refers to a direct reading rod. That's a movable tape rod. I don't have time and I don't have one with me because it requires you standing there, watch me figure out how to use it so I can show you how to use it. They're really handy, especially on things like this, because once you set your first one and you calculate where your what your the top of your well, asphalt in the road case, but the top of your bedding, the top of your, or the flow line where it's going to lie. It's once you get the hang of it, it's easy. But when they say that, be sure you have a direct read rod. That's Linker, they call it. That's the company that makes it. We're not going to do that. And there's only a couple of sentences that I might have to say, don't pay attention to this. One of them says, and it's how to use that linker, without moving the receiver, loosen the tape clip and raise the tape until it reads 10.5. I'm not going to go through all that. I'm just going to say it in terms of like, set the receiver at 10.5 on your grade rod. It gets you the same thing. We'll have to do it. All we got to do is move that receiver up and down. We're not going to be moving no tapes because we're not using a linker rod. Okay, let me not spend too much time here. This little symbol is a cut symbol. That means the trench is going on. This is a 10-foot offset, and it's specific to this station, what it wants you to do at this station. Here is 20 foot down is another cut, and it could be different. It could be a fill, and we'd have to go to what the book's going to show us here. I mean, what the book showed us in working with large buildings, parking lots, and roads. Be the same kind of thing, but they will go through that. The act, I call it a formula, but it's what you need to do once we get there. I just want you to picture this. these stakes are parallel with the center line of this trench. The offset is to the center line of the trench, 10 foot. So that's the same thing as being in line. But the laser is going around and around, so it don't care where the center line is. We do, and this tells us where the center line, but it's just going to go, and when your receiver reads it, now it's going to have a slope to it. And I got another little illustration where, how can I tell these guys what a beam does when it's sloped? Well, it continues to rotate, but it rotates like this, like this thing going around Saturn or something. If you can imagine a turntable, if anybody's old enough to have used vinyl, which by the way is coming back, if you set that turntable down on your table, then it goes around and around, but it has a true horizontal, which is level with the horizon. And then straight up and down through it is, you could call the x-axis. Now, when you add a slope to it, you move that x-axis a little to the right or the left, and your rounding and roundness starts being an elliptical looking thing. But it's hitting everything around it, but it's doing it at a slope. If we were going down, it would be going around and around, high up here and low down there. So that slope's going to keep our reading the same. It's going to tell us that the laser's working. And because these all of these calculations, I got a little description of that coming up later, are based on, like, you don't need a laser level to, well, if you have a laser level and you knew what your your grade was down here that you wanted, what would you do? You would do what we've done. You would find existing grade here, and then that would tell you what your, and you would know the proposed grade. So, because that's from the plans, they know where the elevation is, and from the profile, by the way, that we looked at in the earlier courses, we looked at a plan and a profile. But in the profile, the flow line of this pipe or something would be illustrated and given an elevation, probably from inlet, and an elevation on the outlet, or it would give you a fall. And then, of course, your horizontal distance would, if you didn't know the elevation, if you just had a starting elevation, you would take your percent fall, multiply it by your horizontal distance, and that would give you your vertical difference of where you're going down here. Now, each one of these is going to have 20 foot. So if you've got 2% for the whole thing, then from here to here is going to be 2%, right? So you take here, and wherever this, whatever this reading is, it is. But this proposed grade is going to have, down here is going to be like that. This is 20 feet. If 2%, it's going to be 0.2 lower right here, 0.4 lower right here, et cetera, et cetera. So, but there's a fall from here to here. I think I'm calculating this right. If it's 2% and that's 20, it's 0.4. That's the difference. That's your fall, 0.4 every 20 feet. So I'm hoping this kind of clears it up, what he's talking about. When he says parallel, you can set it over here. He'll talk, or the book will talk about, if you set it over here, you can have a receiver on your backhoe. So you can start digging, setting, and checking all at the same time. You don't have to have your laser up here in the way. It can be over here, and your stakes are offset, so they're not in the way. So you can continue checking, and you can continue digging. It keeps you out of the trench, is what it does. Okay, let's see if I can get us over to the book. Oh, there it is. I need this. I'm gonna see if I can't minimize this guy. No, I'm not. I'll move this guy. I'll minimize this guy first. Well, let's see what happens here. So I want to show you a couple of illustrations when you get to your when you get to your module. I have them implanted in there, and you'll have them labeled. It'll be labeled as uh, vertical offset. Take a look, and that will be an illustration of what's called a banjo, and we will take a look at that actually right now using a layer to set a trench. And this is the video I'm making right now, and this is where it's going. But this vertical offset, let me get over here where I'm supposed to be. Sorry. Now, my errors. The vertical offset. I'm going to have to upload it. It's a file. It's in the Purple Frame curriculum. Some of you that went through the certificate program may have been. No, this is in one of my books. Okay. When the book says put the rod on the hub, he's saying put that grade rod here and measure up to where your transmitter is getting a solid read. This is a banjo. It's really, really handy in subdivisions because, like here, the flow line cut 0.4. Well, look, here's 1 foot of that. So that would be our reading when we get to the book. So you would have to take this 1 foot, and then there's that 0.4 to the top of the curve, right? TC, top of the curve, and then look at the curve section itself. This is your flow line, the gutter of the curve. So this is 8, so this is 6, and this is 8. I wonder what in the world that is. So we got to go down the cut point 4. So we take this 1 foot reading right here. Let me take the 1 foot reading because we got to get rid of the fact that we can't measure across here because it won't work that way. You have to, like a boot, like a grade boot. We got a 1 foot boot here. Hike up really what we got here. So if you take 1 foot, and then if you add, that's our reading here, if you add the cut plus 0.4 plus 0.4, and then that would get you down to the top of the curve, right? Because there's at 1, there's at plus 4, that would get you here. And then 8 inches is what? That's 0.64, I think. Let's just say it is. Plus 0.64. I'm not sure how this math is going to come up, but you see what I'm doing. That's 0.64 of a foot. 6 inches is 5.5 feet plus 0.5. And then that looks like another 6 inches for your sub-base stuff. Let's just say it is. Plus 0.5. So we're going to end up with the 3.04 reading here. I mean, a 3.40 distance down here. And so when we set that grade rod in there, when that laser beam hits it, that's what we want it to read. This, all of this, the cut plus the, I'm calling it an offset, but that'll be our grade rod reading, whatever it is, up here. And then we'll have to add the cut, the top of the curve, this whole curve section, and then the sub-base material down here. So that's what we're doing. And we're just doing it a little bit different and using the banjo. The banjo works, this is 1 by 3, 4, something, 2 by 4 maybe for this. Of course, that's a hub, and this is nailed to it, and this is, we usually put a little, what would you call, a gusset of plywood or something here so it won't wiggle, and then you kind of just tape your level to it, and that way you know your level and you know you're 1 foot above here and you're 1 foot above here, out here at the end of it. So that's that. Now, the next thing I want to show you, maybe this will help as we kind of slip through this course in just a minute. I mean, this section in just a minute, which, by the way, is setting the, no, it's what is it called? Using a laser level for trench work. That's the section that's found in. Okay. I want to show you, that was the banjo. Now, this is, comes out of automated machine control in purple frame. I kind of thought it'd be bigger, but look at this. This is actually a dual slope. It's sloping this way, and it's also sloping that way. But disregard that. He's done what I've done, but he's got his laser set here. And imagine, remember those offset stakes? They would be coming down through here, set, and the trench could be over here. And he's reading it as we're setting our rod on these hubs for these offset stakes, and then we're going to add base or whatever to, the cut that's called for. So you know all this started by looking at the plans, finding out what the desired grade was, and then coming out and finding the existing grade, and then finding the difference between existing and proposed grade, and that would determine our cut. But we was using that offset, so we had to come up a little bit, move the receiver up until we get a solid read on it, and whatever that is, we got to add that cut, the the sub base, and where's the flow line, and all that stuff has to be added to it. So this is a little bit more illustrated of what the book is saying here. So I'm going to get rid of this. I may get rid of the whole module, but uh, let me just go back to the beginning of the module. And maybe I'll let it rest and bring the book over here. Probably finish out on some of my notes and looking at this. Let's make this as seeable as possible. When we do these videos out of this book, I hope you have uh, your your book as you're watching the video. It may be helpful. Now, uh, I talked in the beginning about moving on to the next module after you complete the existing module. I think I said that. That's what I'm going to assume from this point on. And again, like I said in a little bit ago, if we run into trouble, just let me know it's not working. But we got to do something. All of us, many of us, that's still some some uncompleted assignments in week 1, and we're going to be in week 3 Monday. We can't have that. I don't have time, nor do you, to go back and redo things that you forgot, overlooked, or just got in a hurry. So that's why I've cut out the extension. If you get in a bind and you turned in a day late, call me, ask me, I'll change it to a day. But it's going to cost you 10%. I gotta punish you a little bit. I guess I need you to, uh, get your plan together. By the way, the the uh, the tailgate, I forgot what it was that we talked about planning and time management or self-management, the 3 musts. There were some really good ideas in there, real detailed plan. I hope you guys that wrote it stick to it, and you guys that read it will follow it. That was really good. There's a couple of them. So back to this course. We're still using a laser to do trench work. It says it's the fastest. One's capable of a slope beam is the quickest, and I would agree with that. no further than 12 feet from the trench edge. Uh, I don't suggest placing a laser with a sloping beam further than 12 feet from the edge of the trench. And I think that may have to do something with accuracy, but I can't imagine, even if it was 20 feet. But with that slope, it could be an accumulation of error thing. So anyway, I'd follow what they say there to start. So we're going to talk about the twirling beam. We call it a rotating laser, I think. It's laying trenching on a radius. You can do that now, because you don't have to, you're not worried about line with it. You can offset it like in that little picture I drew. It's offset from the center line of the trench. It can be used for trenching and laying simultaneously. And I've already talked about that. The pipe laying and trenching can go on. To set it, it's just got, it uses uh, setting the percentage of slope. There's a percent here somewhere. Anyway, it says they're different. Some of them you just punch in the slope, 0.02 or whatever, you want, and tell it it's plus or minus. And or you can use the up and down key, to get it, and it'll tell you where it's at what slope, at what slope it's sending, and you can move it with those up and down keys. And on some, you just dial the slope in with a knob on the side and say, hit the set button, and it adjusts just like it automatically levels. By the way, this is really a good idea when you're doing these kinds of things, because you read it in the shop and you think you got it, and you get out there in the field, and lo and behold, what was that thing saying? Okay. Setting up the laser for trenching. Uh, Let me go through this. In here it says once you've dialed in the slope, you've got your laser set, and you're ready to set up the grade rod. Be sure the survey rod you use is a direct read rod. Now, if we had time and we had videos or anything to do with this, I would follow this, but this is not going to make a difference in this case. So set the laser at the point behind the trench that's higher than the surveyor's hub. Wherever you set it, make sure it's higher than the surveyor's hub or any of those uh, hubs that we're going to be reading, or you won't be able to read it. All right, set the hub, set the rod on a hub that's about 25 to 50 feet away. Now, I'm just going to say right here, and these are just notes I made after reading this thing. I showed you that banjo, and let's see. I showed you what that I wanted to show you. No, here we go. It says set the hub on a rod on a hub that's 25. Well, I'm saying set the rod on the first hub. Remember the drawing I drew? It kind of just makes sense to me to go in order on these things. Now, if you went down 25 feet away, you should still get the same read on it, on that hub that you got on your first hub, because the laser beam is accommodating for the slope as we move. So set the rod on the first hub or the beginning at 00. Depending on your direction, which you will find in the profile view of the plans, you're going to have a rise if the slope is designated as a plus, or you're going to have a fall if it's designated as a minus from your starting point. Move your receiver up and down until you get a solid tone. Now that's after you've set your rod on whatever hub. I want you to set it on the first one, I would. And you move that receiver until you get a solid point, and then tighten your receiver right there and note the reading on the receiver at the pointer that's on the receiver. What does it read on the rod? Now go back to your book, top of page 99. I have a little note written there. Uh, that's all of my notes. I have a little note that you think about that banjo, but if you could measure from the real hub down, if you extend a string line 90 degrees from the hub across the trench, the distance from the stream line to the flow line would be the same as the desired cut is saying, because that cut is from the top of that hub. We just can't lay down on the ground and do it. So we had to bump up, and that banjo brings it up a foot. The advantage of taking a shot on the hub just simply keeps you out of the trench, and it's a whole lot quicker. Now, in the book, I'm in the first paragraph, top of page 99, about the last sentence where he says, let's say you measure up, that's after you set it on the hub, 2.60 feet. And the cut the surveyors have marked on their stake is cut 7.90. Add these two numbers, your 2.60 and your cut of 7.9. Add these two numbers together and you would get 10.5. And then it says 7.9 plus 2.60 equals 10.5. Now ignore this sentence without moving the receiver, loosen the tape, just ignore that, and then just set the receiver at 10.5 on the rod. Just set it there at 10.5 because that's what you're going to get. And that will take in consideration your cut, your top, whatever that we got to add to it. In this case, all we're having to add to it is just the cut, I think. Yes. It's just, he's not having to, you're going straight to subgrade is what's happening here, which is cool. So ignore without moving the receiver, loosen the tape, and all you do is just set your receiver at 10.5. Now with that slope set, everywhere you go, you need to read 10.5 on that receiver because the slope beam is going to stay the same and your trench is going to have to accommodate the grade rod. So if you move down and you're too high, you're not reading 10.5, figure out what you need to do to get to 10.5, you know. So you put a piece of tape on that one video that you'll see at subgrade, call it, and then see what you are getting. So you would have the piece of tape that 10.5, so you move your receiver and see what you are getting, and if you're getting 8.3, you know you're too high, so you're going to have to go down that distance until you can get it to read that 10.5. I hope that's clear. Then it says walk on down, and I just say to the next hub, it says 75 feet down, and the same thing, do the same thing with the exception, but you don't move the tape. But again, forget that. Slide the receiver until you get a steady on-grade signal, then measure from the hub to the pointer, just the same thing you just did. In this case, you're going to get a reading of 2.92, and you have a cut on that stake at 7.58. So it says add these two numbers and you'll get 10.5. 7.58 plus 2.92 is 10.5. The cuts are accommodating for you to keep the same reading at subgrade. Now remember, the slope on as long as you continue to get the same reading at each hub, and you may have to cut or fill to get that reading. Remember that. You may have to, like I said, move it off that 10.5, keep a piece of tape on 10.5 so you set it back, and take out dirt or put in dirt until it will read 10.5. So there are 3 grades that must be set to trench: grade and lay pipe. 3 grades that must be set to trench, grade, and lay pipe. The first rod reading is the grade the hole will dig to. That's what we just did, including the undercut for the pipe bedding and other material, if any. To determine the amount of undercut, you need two measurements: the amount of pipe bedding and the thickness of the pipe. Like that, what do you call that? RC, RCP, reinforced concrete pipe. The wall on that thing's like uh, maybe 2 or 3 inches. So you would have to go down as low as the outside diameter where you're going to lay the pipe, and then you'd have to go a little 2 or 3 inches more to accommodate the wall, and then you would have to add whatever bedding is going to be under the pipe, and that's what we've been doing. Here's I think another example. Well, I'll read it. We say the plans are job specification. Well, we'll say the plans call for 0.4 foot. Excuse me. Of bedding under 10-inch clay sewer line. To get the pipe thickness, just measure the end of the pipe before you put it in there. We'll assume the pipe is 0.1 foot thick. Now we have to measure. We have both the measurement of the 0.4 foot bedding plus the tenth of a foot thickness of the pipe, and that equals 0.5 feet. So our undercut, would be 0.5 feet. Once you determine a 0.5 undercut is needed, just slide the receiver, not the point. This is a direct read. You just get your cut. Do your cut. Forget the moving the tape. You don't have one. You don't need one. Then we want to start placing and grading our base, our base material, so we can lay pipe. So we got the subgrade done. Now we're putting bedding material in there, which could be an aggregate of some kind, or some kind of number 3 base, or I don't know, gravel sometimes, sand sometimes, just depend on what the specs call for. We must set up a grade rod for the finished bedding grade by adding the thickness of the bedding material. So again, back to the 10 foot plus the 0.4 equals 10.4. So just set it at 10.4, and that tells you where your bedding is. I think we've done enough. There's a little conglomeration on over here with a pole with a laser on it, and I think that's a pipe setting, and it looks like a grease. I think that's using a pipe layer. That's a grease bucket on top. Anyway, what I'm going to do is I'm going to leave the rest to you on this thing. What I want you to do now, unless I throw in an assignment based on what we've just talked about, just take it from page 100 all the way to what? 111, 113, probably 114, and read that, and there'll be a quiz in there when you get to it. That's over the whole book, but if you read this, you'll know the rest of this book, it doesn't have all of those, how to read this, how to read that, and allow for this. The rest of it just talks about mounting the laser on scrapers and how you would calibrate your scraper, and how you would calibrate your dozer blade. It's just mostly kind of interesting about how to get it started, where to mount it, and setting up a rover, an antenna, a base station, and telling you what's important, what must be checked, and things like that. It's just some interesting stuff. It goes into telling you to set daylight stakes, and if you have some questions about that, some places you'll have oh gosh, your proposed cut will be way up in the air, and you'll need to set, like I've had to tie stakes on top of each other, overlap them, and tie them with ribbons so the scraper guy could tell when to quit cutting. So I could put him a grade mark so he could see it. But it talks about that uh, a little bit in here, things that you might come across, uh, not issues, but just normal things you got to accommodate for. And it talks a little bit about the remote readout things and things like. And then the initial setup from talking to people. Not that I've been around it that much. That's the biggest deal. Once you get your model built, and you have to build a 3D model, and I don't know anything about that. You have to build a 3D model that will go into your GPS and all of that things. But setting that up, setting the base station up, it has to be plumb, it has to be set up just right. Uh, it'll tell you how many satellites you need, at least how many satellites, probably 5. But anyway, it's a kind of an easy read, maybe a little interesting, and then just answer the quiz. And I'm hoping to get you a little simple assignment in there to see if I did what kind of job I did of conveying what this book is talking about. And with that, uh, I'll I'll probably see you at some point Monday, or you'll hear from me. Remember, let's get the current module done before we move to the next one. Now, for those of you who finish your current module, I'm not going to make you wait. When it comes the next week, I'm going to open the module. I just don't want you to do anything in it until you finished your first one. Clean up behind yourself. I promise you things will go smoother for you.